As Dr. Blatchford mentioned, I've had the opportunity to work with broiler breeders in both my master's and my PhD. I just started at the University of Arkansas, so a lot of what I'm going to be talking about today is stuff I did and learned and did research for at NC State. So I'm a little bit of a dual representative today. But I'm going to be talking about the broiler breeder feed paradox from a welfare perspective. So, a brief overview. Broiler breeders are the parent stock of broilers, which are meat production birds. The way the U.S. poultry industry is set up is we have the pedigree, great-grandparent, grandparent stock at the top, and then the parent stock are the broiler breeders, which is the step right above broilers, right here. And so because of that, I'm going to talk about broilers a little bit before I get into broiler breeders. So broilers have been genetically selected for increased appetite and faster growth rates. Many of you, I'm sure, probably have seen several different variations of this image, but this shows the genetic selection for growth rate in broilers over the past several decades. In 1957, 56 broilers at 56 days old would on average weigh less than a kilogram. By 2005, genetic selection has allowed them to weigh over 4 kilograms, and that genetic selection has continued to today. And so because of that, broiler breeders, their parents, share similar genetics for appetite and growth. However, broilers and broiler breeders have significantly different production lifespans. So breeder lifespans or breeder production is measured in weeks and can last up to a year or more. The rearing period is typically classified as 0 to about 20 weeks, and then the laying period or breeding period is 20 weeks up to 60 weeks, whereas broiler production is measured in days. So typically, at least in the US, 42 to 56 days. So much, much shorter than breeder production. Another important difference is that broilers, in addition to laying hens, they have very specialized functions. Broilers, their primary purpose is fast growth rate for high meat yield, and that's kind of what they're raised for. And then with laying hens, their purpose, they have lighter body weights for egg production, and those two kind of go hand in hand. And that's kind of what the focus is on for selecting for these birds. Whereas breeders, they have more of a multifaceted function. So they have to carry the genes for fast growth rate and high meat yield in order to pass it on to broilers. But they also need to have egg production, high egg production, particularly fertilized egg production. And so they kind of have to do a little bit of both of what layers and broilers do. The problem is that high growth rate and appetite, in combination with this longer production span that's kind of more similar to laying hens production span, increases the potential for obesity, health issues, and reduced reproductive function. And so we have this broiler breeder paradox where increased body weights decrease egg production. But with broiler breeders, we need both. So how do we get around this? The kind of simplified answer to that is feed restriction. There are two types of feed restriction. There is quantitative and qualitative. Quantitative feed restriction is the most common. It is just reducing the amount of feed given. And so there are two different ways this is done, one of which is skip-a-day feeding, and this is just providing feed on alternative days. However, this can be done in a few different ways. You could have a true skip-a-day feeding regimen, which is shown on the right, where feed is just given every other day. But you could have other variations, such as a 6-1, 5-2, or 4-3 program. And that just kind of entails the on-feed versus off-feed day numbers. So like for a 4-3 program, you would have 4 on-feed days during the week and 3 off-feed days. And then similar with 5-2 and 6-1. For everyday feeding, you have daily provision of feed, but you're getting smaller quantities. And so with both everyday and the different skip-a-day feeding regimens, the same principle applies where the more frequently you feed the birds, the smaller the portion sizes are going to be. So At skip a day would probably have the true skip a day would probably have your biggest portion size, whereas every day would have your smallest portion size. And so this quantitative restriction leads to a 20 to 80% reduction of ad libitum intake. So it's 20 to 80% less than what the birds would prefer to eat, what the desired intake of the birds. And this can vary based on where they are in the reproduction cycle. They're feed restricted in both the rearing and the breeding stages, although feed restriction tends to be more severe during the rearing stages. Also, both males and females are feed restricted. Qualitative feed restriction, this is also referred to as an alternative diet. This is adding non-nutritive feed additives to either reduce the caloric density while increasing gut feel and satiety. So through adding things like fiber. Some common additives are soybean hulls or oat hulls. Another thing that's added is appetite suppressants, and this is to voluntarily reduce feed intake. This is not as common. There are some criticisms to it, especially with the word voluntary, which is why that's in quotations. And haven't really shown that, or there's kind of a thought that this may have a negative impact on the bird. So it's still being researched, but it's not used as often. However, qualitative feed restriction alone is not enough to control body weights, which is kind of the whole purpose of feed restriction. So it's usually combined with quantitative feed restriction, and this is known as a rationed alternative diet. So I know we're talking about the five freedoms today. The five domains today, but I'm going to talk about the five freedoms just for a second. And I'm sure as all of you have seen these before, but just briefly, the five freedoms are freedom from hunger and thirst, freedom from discomfort, freedom from pain, injury or disease, freedom to express normal behavior, and freedom from fear and distress. But what happens when one of these freedoms contradicts some of the others? And this is where the broiler breeder paradox kind of leads into the feed restriction, or that leads into a welfare paradox. So we have freedom from pain, injury, or disease. And so the whole point of feed restriction is that it is supposed to prevent obesity and other health issues in breeders. However, one of the effects we get from this is that we're not necessarily meeting that freedom from hunger and thirst. We also have these birds with strong appetites that are being feed restricted, so we're likely experiencing some discomfort there. And so this paradox, along with a bunch of other ones, is kind of one of the reasons why we've shifted to the five domains over the last several years. And so this is more of kind of an additive view of welfare, looking at our physical functional domains, nutrition, environment, physical health, and behavior, how different positive or negative impacts of those impacts or affects mental domain, the overall positive or negative experience of the animal, and eventually welfare status. So if we plug feed restriction into this, first I'm going to talk about physical health. The whole purpose of feed restriction is to reduce disease. So we'll say with feed restriction, we tend to have positive physical health. Next, we look at nutrition, the nutrition domain. And before I go into that, I would like to define hunger for a second. So De et al. 2009 defines hunger as a negative subjective state experienced by an animal that is chronically undernourished. Now, what does undernourished mean? A lot of times we think about undernourished as not as the nutrient needs not being met. So specific vitamins, minerals, amino acids, things like that, not having those needs met. However, when it comes to broiler breeders, their diets are formulated to where those needs are still being met even under feed restriction. So we don't really have that. But De et al. Proposes another perspective of undernourished, which is intake is falling short of its desired intake. And so in that case, we do have that with broiler breeders. And so we can go ahead and say that likely breeders have a negative nutrition domain. And so we have one positive, one negative. How do we really know what that mental domain or what that overall welfare status is? And the answer to that question is one of our other domains, behavior. So what are some behaviors that are commonly caused by feed restriction. One of the most common ones is abnormal repetitive and redirected oral behaviors. So this is excessive foraging, feather pecking, drinker pecking, and I'm going to go ahead and say this is the one I'll probably be talking about the most, particularly drinker pecking, as this is what my master's research focused on. But some other behaviors we see are increased anticipatory behavior and activity. So this indicates that birds are agitated, probably due to their state of chronic hunger, and also increased rate of feeding and increased motivation. So they typically eat very quickly, are very motivated to eat, and that also kind of indicates that they're in a state of chronic hunger. So abnormal repetitive behaviors. ARBs are a phenomenon we often see in livestock, including poultry. We see this in feather pecking in chickens, also tongue rolling in cows. It can be induced by a few different things, including frustration, repeated attempts to cope, and central nervous system dysfunction. And it often can present as either pecking at a flock mate or objects due to unsatisfied motivations. In the case of poultry, this could be unsatisfied foraging motivations. One type of ARB is polydipsia, and this is classified by excessive water use. And so this is something that is seen in broiler breeders, as feed restriction practices tend to cause higher drinker use in broiler breeder pullets. You can see in this paper by Hawking 1993, which shows water intake for birds under different treatments. It shows both broiler breeders and layers, as layers are also feed restricted. The broiler breeders are in the black, the layers are in the gray. But when you look at ad libitum fed birds compared to restricted fed birds, you can see that the water intake in restricted fed birds increases. And this is potentially due to, like we said, limited foraging and increased frustration resulting in this abnormal repetitive pecking behavior directed at the drinker line. So because birds are feed restricted, they eat their feed really quickly, and they might not have as much of an opportunity to forage. They're also in a state of chronic hunger, so they may be taking out that frustration on the drinker line as well. So this polydipsia can lead to water spillage, wet litter, and consequently pododermatitis, or foot pad lesions. As a result of this, excessive drinker use has led to water restriction practices and being used in some parts of the industry. And so this would just be turning off water for certain parts of the day. This is that same graph by Hawking 1993. It shows restricted fed broilers with free access to water versus restricted fed broilers with limited access to water. And it shows that limiting water access does decrease water intake. I'm not going to go into as much detail about water restriction, but it is important to my experimental design and some of my research, so I just wanted to briefly mention it. In looking at different feeding regimens in broiler breeder feed restriction, previous research has found that there is increased drinker use in skipidae birds compared to everyday treatments. In this paper by Mercy et al., which shows mean performance or mean percentage of time performing drinking behavior by week, which is on the x-axis, looking at skipidae birds, which is in that dotted line or dashed line, they had increased drinking behavior compared to daily birds, particularly during the rearing period, so that 10 to 20 week period. We also see differences in drinking behavior based on the day, on-feed or off-feed days, because skipidae birds drink 150% more on-feed days than on off-feed days. And this is because water intake is driven heavily by feed consumption. Looking at qualitative feed restriction, we've found that the inclusion of insoluble, or previous studies have found that the inclusion of insoluble fiber decreases water intake and litter moisture. They've also found that diets without fiber have performed more drinking behavior than suggested by water use. So birds are pecking at the drinkers more, but they're not necessarily extracting that water, which kind of indicates more of an abnormal repetitive behavior. So with my research, I looked at drinking behavior in 960 cob, 500 fast feather pullets from 0 to 23 weeks, which is when they are most heavily restricted. And I did only look at females and not males. We looked at we put the birds in 16 pens with 60 birds per pen, and we assigned each pen to 4 different treatments. So we had a skip-a-day feed treatment with ad libitum access to water, skip-a-day feed treatment with water restriction, an everyday feed treatment with ad libitum access to water, and an everyday feed treatment with water restriction. And so that water restriction entailed turning the water off for 3 hours each day. We also had increased fiber in the everyday diets, and we did this per industry standards, as that is typically what is done in everyday diets within the industry. So we measured a bunch of different things, but what I'm going to present today is drinking behavior. We video coded, or we looked at video recordings of drinking behavior, and coded them looking at 10 birds per pen. We did this on an on-feed day at 16 and 22 weeks of age. And we looked at 20-minute video segments at 3 different time points during the day. So at 1 hour after feeding, which is typically that peak drinking time for those birds. We looked at 12 o'clock, which was the onset of water restriction for our water restricted birds. And we also looked at 2:30 p.m., which was the end of water restriction for those birds. And this is kind of a view of what our video observation would look like. The focal birds were colored with livestock marker for identification. We also looked at average bird water use over a 24-hour period, also on an on-feed day. And we did this at 4, 10, 16, and 22 weeks. And this is a picture of how we recorded or measured that drinking behavior. We put 5-gallon carboys on top of ladders outside of each pen, and we would manually turn them on and off to mimic the water restriction, and also weigh them to get that water weight and water use over the 24-hour period. Here is how we did our statistical analysis for this. We used our software using linear mixed effects models for both drinking behavior and bird water use. Although we square root transformed the data in drinking behavior. We also used separate models for each of those time periods in drinking behavior. In both models, we used feed treatment, water treatment, and age as fixed effects, and we included pin as a random effect. We then did a stepwise backward reduction using ANOVA for model comparison and determined significance at p less than 0.05 and used Tukey's pairwise comparisons to decipher those differences. So for our results, we didn't really have any interactions in drinking behavior, but we did see a main effect of feed treatment, which I'm going to show you here. In this graph, on the y-axis, we can see total drinking duration per focal bird per 20 minutes in seconds. And then on the x-axis, we can see this in weeks, so 16 weeks and 22 weeks. And we had this divided by each time point, the everyday birds being in orange and the skip-a-day birds being in green. So at an hour after feeding, we saw that the everyday birds drank significantly more than the skip-a-day birds at both ages. However, during those afternoon time periods, so at 12 o'clock and at 2:30 p.m., we saw a switch at 22 weeks with skip-a-day birds drinking significantly more than everyday birds at both those time periods. And so there are a few different reasons why this could be. I think the main reason is likely due to those portion sizes. So whereas everyday birds get smaller portions, they eat it much quicker, and typically birds will eat all their food and then they will start drinking. So that's likely why you see them drinking more during that hour after feeding behavior. Whereas skip-a-day birds have larger portions, so it takes them longer to eat their feed, and so they would drink later on during the day. Although that increased drinking behavior at later time periods could also be indicative of an abnormal repetitive behavior. However, that is not entirely clear based on the data we have. Looking at our average bird water use results, we did have an interaction between feed treatment and water treatment. So this graph shows water use per bird in grams on the y-axis and age in weeks on the x-axis, and we had this split by water treatment. Again, we have everyday birds in orange and skip-a-day birds in green. And so in both water treatments, we see that skip-a-day birds drink significantly more than everyday birds at 10 weeks of age. However, in the ad libitum water treatment, this switched where everyday birds drank significantly more than skip-a-day birds at 16 and 22 weeks. However, this was leveled out by water restriction. We aren't entirely sure why this is. Um, the increase in skip-a-day drinking behavior at 10 weeks is similar to the study I showed previously by Mercia et al., where skip-a-day birds drink more during earlier time periods. However, that switch to everyday birds drinking more, that could potentially be because we had a dietary change at 16 weeks, switching from grower to developer diet. So it could be that different birds on different feed treatments cope differently with dietary changes, or it could mean that those everyday birds are performing abnormal repetitive behavior. But the one thing that we do know is that drinking behavior and our water use are not really telling the same story. Where we have increased drinking behavior in skip-a-day birds at those afternoon time periods at 16 and 22 weeks, but we have decreased water use. And so this could be indicative that the skip-a-day birds are actually performing abnormal repetitive behavior. Um, as Nielsen et al. Showed that birds that aren't provide fiber, or don't have fiber, which the skip-a-day birds didn't have that extra fiber added, show more drinking behavior than indicated by water use. So again, those birds are pecking at that water line without actually extracting the water, which is more indicative of an abnormal repetitive behavior. Although that's not to say that the everyday birds weren't doing that as well or weren't performing abnormal repetitive behaviors. That kind of gets into water consumption versus water use. So we can't be sure that the birds were drinking the water as they were using it, and we can't be sure that the birds were extracting water as they were pecking at the water line. And so we aren't 100% unsure that, and it's really hard to measure consumption versus use. But this is kind of what our data shows, that there might be some different motivations or some different coping styles with each of the feed treatments. So some other redirected behaviors and besides drinking behavior includes feather pecking. Skip-a-day birds in previous studies have been shown to have more feather pecking than everyday birds. And this, again, could be because of their chronic hunger. However, when we look at other behaviors like anticipatory activity, which is another sign of chronic hunger, we actually see increased resting in skip-a-day birds compared to everyday birds during this rearing. So kind of an opposite effect of what we've seen with redirected oral behaviors. We see that skip-a-day birds also perform more dust bathing and preening, so more comfort behaviors. And we see that everyday birds, or previous studies have seen that everyday birds showed higher activity levels prior to feeding, so greater anticipatory activity. This, again, could very well be due to the portion sizes, where everyday birds are fed smaller portion sizes. Therefore, it is possible that they never get satiated after feeding. Whereas the skip-a-day birds do at least get some sort of satiety or gut fill at least on their on-feed day. Um, and so we see chronic hunger behaviors indicating chronic hunger in both feeding regimens, just we see them displayed differently. So back to our 5 domains, we can go ahead and say that birds under feed restriction are showing some negative behavioral signs, potentially leading to an overall negative experience and welfare status. So is there anything else we can do about that? We have both of our feeding regimens show some signs of chronic hunger. Are there any other options? Precision feeding is another option, and this entails birds, is a precision livestock system where birds are weighed, and if they are at optimal or below optimal weight, they are given feed. And so then this leads to opportunity where they can be fed multiple times a day, potentially providing more foraging opportunities. However, this is not really applicable wide scale. Research has shown some that precision feeding can improve some signs of chronic hunger in birds. However, other signs are still present. And it's also just very difficult to implement this on the industry level. Another option, scatter feeding, which is done a lot, particularly in Europe. In Europe, skip-a-day feeding is actually banned, and everyday feeding is the only regimen used, and they typically do scatter feeding with that. This is just kind of scattering the feed throughout the litter to kind of elicit that foraging behavior. And so it allows for greater expression of foraging, but it's still not meeting that desired intake, and birds still show some signs of chronic hunger. And lastly, another option is potentially increasing feeding frequency. So instead of feeding them once a day, feeding them twice a day or 3 times a day. However, we're still kind of getting in that issue of portion size versus frequency, where the more frequency or the more frequently you feed the birds, the smaller the portion sizes will be. And birds still tend to show that anticipatory activity and chronic hunger when they have smaller portion sizes. So in summary, there are some positive health benefits of feed restriction, but overall it negatively impacts the welfare status of animals. But it is necessary to maintain production. There's not really a clear answer on how to improve the welfare status of birds under feed restriction. Varying feed frequency and quality has shown some potential benefits, but chronic hunger is still apparent. And one thing I just kind of wanted to bring up that I've learned from presenting this research, from talking to people in the industry, is something that we as scientists maybe don't like to say a lot, but it could be very well situationally dependent. There are a lot of different factors that impact the way birds cope with feed restriction. Um, and maybe something that works for one flock or even one individual bird doesn't work for the other. And so trying combinations of a bunch of these different solutions may help, and doing different things for different flocks may be the answer to the problem. But what is known is more research is definitely needed because this is necessary to maintain production. Feed restriction still needs to be done, but we want to mitigate this stressor as much as we possibly can. And in order to do that, we need to find more ways to do that, find better ways to do that. And for my acknowledgments, I like to thank Dr. Poulin for helping me with this research and being my mentor through my master's, as well as Dr. Weimer for giving me the opportunity to speak here today. My project in particular was funded by COP Research Initiative, and our water lines were also donated by Ziggity Systems. I'd also like to thank my collaborators, Dr. Ramon Malheiros, Dr. Lisa Belke, and Dr. Sarah Orlowski-Workman for their help on this project. And then as well as the NCSU Chicken Unit and Feed Mill staff and the Poultry Welfare Lab and Prestige Department of Poultry Science, who gave a lot of support with this project. Any questions?
Thank you, Allison, for a really great talk.